Hi everyone. Today is part 2 talking about radicals, and we're going to do simplifying radicals today. Now, in part 1, what we did was approximate radicals, and that's when we took a square root of some number and we said, okay, it equals about this, like maybe 2.7 or 10.3 or something like that. We gave a decimal answer that said what it approximately equals. Now, today we're going to learn how to do something called simplifying, which is actually a very different problem. So I really want to make sure that you understand the difference and separate them. Don't get them mixed up. So if we take a quiz or a test and I say simplify this, I want you to know what to do. But if I say approximate this, I want you to do that instead. So here's what we mean by simplifying radicals. Simplifying means you're going to leave it as a square root. You're not going to give me a decimal answer, but you're going to factor out any perfect squares. So what you want to do, you want to take a look at the number inside the radical and see if it can be divided by any perfect squares. And remember, we went through the perfect squares in part 1. That was any whole number square. Now, if that number inside the radical can be divided by a perfect square, then do that and separate it and simplify it. So let me show you how that's done. We want to simplify, not approximate. I don't want a decimal answer because I said simplify, not approximate. We want to simplify the square root of 45. So I'm going to go off to the side here. I'm going to take that number, 45, and let's do a factor tree for it. We've done factor trees several times this year. Now 45 could be 1 times 45, not 2. Could be 3 times 15. Not 4, could be 5 times 9, not 6, not 7, not 8, and then we're back to 9, so we're done. Now what I'm looking for this time, I'm looking for a number on that list that's a perfect square. And the one I see is the 9. 9 is a perfect square. So what I'm going to do is this. I'm going to take that square root of 45, and I'm going to say, well, 45 is 9 times 5. And remember, I chose that because the 9 is the perfect square. Now what you can do is you can actually just separate those two numbers. They're both still square roots. So this is the square root of 9 times the square root of 5. Now, after you separated them, and because 9 is a perfect square, the square root of 9 is 3. That's why we picked that. That's why we picked perfect squares for this one. The square root of 9 is 3. Now the square root of 5 is just the square root of 5. We're going to leave that. And that is the simplified answer to the question. So what you're doing when you're simplifying a radical is you're thinking all of its factor pairs. You're trying to find one that is a perfect square. If you do, you separate them. The square root of the perfect square turns into a whole number part, and what's left over is a more simple radical. Instead of the square root of 45, we just have the square root of 5. Now it's very important to notice it has to be a perfect square for this to work. Like if you took your 45 and you split it up into 3 times 15, it just doesn't do anything because nothing simplifies. If I wrote this as the square root of 3 times the square root of 15, even if I split it up, the square root of 3 times the square root of 15, that doesn't help me because the square root of 3 and the square root of 15 don't simplify. They're not perfect squares. So don't do that. That's what we do not want to do. This only works if you can find a perfect square factor. All right, so here's some hints for you guys as you're working on this. Number 1, not every radical can be simplified. So I said if a number has no perfect square factors, just leave it. So let's say you're doing, I said for my example, let's do the square root of 14. So you go, all right, well 14 is 1 times 14. It could be 2 times 7, and then that's actually it. 3 doesn't work, 4 doesn't work, 5 doesn't work, 6 doesn't work, and we're back to 7. So I look at the list and I go, well, none of those are perfect squares. 1 isn't a perfect square, 2 isn't, 7 isn't, 14 isn't. Okay, well, it's already simplified then. So you just leave it. So don't think you have, like, don't try to break it up into the square root of 2 times the square root of 7 and try to like force it to be simplified if it can't. And then number 2, sometimes numbers have more than one perfect square factor. And if that's the case, pick the biggest one. So I'm going to show you an example that shows you one that has more than one perfect square factor and what happens if you don't. Okay, so for this one, let's simplify the square root of 72. And I'm going to go off to the side. I'm going to make my factor tree for 72. And let's list all the pair of numbers that multiply to give me 72. There's going to be kind of a lot of them, but that's okay. We have 1 times 72. We have 2 times 36. We have 3 times 24. We have 4 times 18. 5 is the first one that actually doesn't work. We have 6 times 12. 7 does not work. We have 8 times 9. And then that's the end of the list because we got back to the 9. So if you start looking for perfect squares, I'm going to skip the 1. In fact, you can always skip the 1. Everything's divisible by 1 and it doesn't do any good to factor it out. So even though technically 1 is a perfect square, don't think about that one. So not counting the 1, we have a 4, that's 2 squared. We have a 9, that's 3 squared. And we also have a 36, that's 6 squared. So this one has 3 possible perfect squares. And what I told you guys on the last slide is always pick the big one. So the correct way to do this question would be to use the 36 and the 2. But what I'm going to do is I'm going to work this question out 3 times. I'm going to do it with the 4, the 9, and the 36 just to show you what happens. So let's do the 4 and the 18 first. Let's say I'm going to take my square root of 72 and I'm going to write it as 4 times 18. And you go, okay, well, then we split it up. Square root of 4 times the square root of 18. And you say the square root of 4 is 2. That was my perfect square. So that becomes a regular 2, and then I leave the square root of 18. Okay, now let me do it with the 9. So I'm going to say my 72 could be 9 times 8. And then I split those up. The square root of 9 times the square root of 8. And I say the square root of 9 is 3. So I'm going to turn that into a 3 and leave the square root of 8. Now the third way to do this, and this is going to end up being the right way to do it, would be to write it as 36 times 2. 36 times 2 is 72, 36 is the perfect square. So I split that one up, square root of 36 times the square root of 2, and then I say the square root of 36 is 6, that's my perfect square. So I get 6 radical 2, which is the correct answer. Now all 3 of them were done correctly. The problem is the first 2 aren't finished. See, if you think about it, this one right here, this 18 is 9 times 2, and 9 is a perfect square, so that can still be simplified more. Same thing with the 8. This 8 is 4 times 2, and 4 is a perfect square, so it can still be simplified more. So it's not finished. The work is right, but it's not done. So basically what we're saying here is, if you have more than one perfect square, if you pick the biggest one, you'll be done with the problem in one step. The right answer to this question is 6 radical 2, or 6 times the square root of 2. You could get there from the first 2, but you would have to simplify again. You'd have to do 18 is 9 times 2, and the square root of 9 is 3, and 3 times 2 is 6, and you would end up with 6 radical 2. And same thing on the yellow one. But you don't want to do it in 2 steps. So if you take a minute at the beginning of the question to make sure you're picking the biggest perfect square, then you know you'll be done simplifying in one step instead of having to do more work.